Hi everyone. First question for the day is question number 26 of the chapter Some Basic Concepts of Chemistry. So this question says if 10 volumes of dihydrogen reacts with 5 volumes of dioxygen gas, how many volumes of water vapor would be produced? We are provided in the question that dioxygen and dihydrogen are reacting together to provide water vapor. So let us see the equation. We know that dihydrogen plus dioxygen is giving us water vapor. Now let us balance this chemical equation. To balance this chemical equation, let us put a 2 over here and similarly a 2 over here. So there are equal atoms in both reactants and products. So this is the balanced chemical equation. From the balanced chemical equation, we can say that when 2 volumes of dihydrogen is reacting with 1 volume of dihydrogen, we are getting 2 volume of water vapor. In the question, we are asked how much amount of water vapor will be produced when 10 volumes of dihydrogen is reacting with 5 volumes of dioxygen. I hope by now you already know the answer. We can say that when 2 volumes of dihydrogen is reacting, we are getting 2 volumes of water vapor. So, when 10 volumes of dihydrogen is reacting, we should get 10 volumes of water vapor. So, this is the answer. To answer such a question, all we have to do is to write down the chemical equation, balance the chemical equation, and then you can easily give the answer. The next question is question number 27, and the question says, convert the following into basic units. And we have 3 questions wherein we have to convert these 3 into their basic units. To solve such a question, I want you all to memorize this table that is given here. If you have memorized this is a very easy question. We have the first question. It is to convert 28.7 picometer into its basic unit, that is meter. We already know from the table that 1 picometer is equal to 10 power minus 12 meter. Now we are asked to calculate how much is 28.7 picometer. All we have to do is this 28.7 multiply with this 10 power minus 12, and then we get the answer as 2.87 into 10 power minus 11 meter. For the second question, we are asked to calculate how much is 15.15 picometer. It's very similar to the first question. As we have done in the first question, we already know that 1 picometer is 10 power minus 12 meter. Now we have to calculate how much is 15.15 picometer. To do this, we simply multiply it with this 10 power minus 12, and then we can rewrite this as 1.515 into 10 power minus 11 meter. So we have done the second question. Let's move ahead with the third question. Third question is to calculate how much is 25,365 milligram. So here we have to convert into its basic unit, that it is gram. From the table we know that 1 milligram is equal to 10 power minus 3 gram. Now we have to convert how much is this. So all we have to do is, as we have done earlier, simply do the multiplication. We get 25.365 gram. Now let us convert this 25.365 gram to kilogram. For this we know 1 gram is equal to 10 power minus 3 kilogram. Now let us do the multiplication into 10 power minus 3 kilogram, or we can simply write this as 2.5365 into 10 power minus 2 kilogram. Next we have question number 28, and the question says which one of the following will have largest number of atoms. And then we have 4 questions. Let's try solving this question. In the first question, we are asked to calculate how many number of atoms are present in 1 gram of Au, that is gold. To solve this question, let us first calculate the number of moles of gold. We know that number of moles of gold is equal to given mass upon molecular mass. Now we know that the given mass is 1 gram. So we put it as 1 divided by molecular mass of gold is 197. So these many number of moles are present in 1 gram of gold. Now we know that in order to calculate the number of atoms, we have to multiply this number of moles with the Avogadro number, that is 6.022 into 10 power 23. By doing this, we get the number of atoms present. So let's do, we get that we already have number of moles as 1 by 197. Multiplying it with the Avogadro number is 6.022 into 10 power 23. Let's put it as 6.022 into 10 power 23 divided by 197. Solving this, we have 3.056 into 10 power 21 atoms. Now we have 1 gram of sodium. Similarly, as we have done in the first question, let us first calculate the number of moles. For this, we should divide the given mass by the molecular mass. Here again the given mass is 1 divided by the molecular mass of sodium is 23. So these many number of moles we have. Now to calculate the number of atoms, let us multiply it with the Avogadro number, that is 6.022 into 10 power 23. Solving this, we have 6.022 into 10 power 23 divided by 23. The answer is 2.618 into 10 power 22 atoms. So these many number of atoms are present in 1 gram of sodium. Similarly, let us try doing the third question, that is 1 gram of lithium. Let's first calculate the number of moles, wherein we divide the given mass, that is 1, by its molecular mass. For lithium it is 7, and then multiply it with the Avogadro number, 6.022 into 10 power 23. Solving this, we have 6.022 into 10 power 23 divided by 7. This is equal to 8.602 into 10 power 22 atoms. Let's do the last question, wherein we are asked to calculate the number of atoms present in 1 gram of chlorine. Similarly, let us first calculate the number of moles. So for this, we divide the given mass, which is again 1, by its molecular mass, that is 70. We know that the atomic mass of 1 chlorine is 35.5. Since here we have 2 atoms, we should multiply it with 2. So we get 70. Now this is the number of moles. And then to find the number of atoms, we do this multiplication with the Avogadro number, which gives us 6.022 into 10 power 23. Solving this, we have 6.022 into 10 power 23 divided by 70. We get the solution as 8.602 into 10 power 21 atoms. Now we are asked to calculate which among the following will have the largest number of atoms. We have calculated the number of atoms for each of the samples, and these are the number of atoms. By looking at the solutions, we can say that in the case of lithium, we have the largest number of atoms. So let us write the final answer as 1 gram of lithium has the largest number of atoms. And this is the answer for this question. Question number 29 says, calculate the molarity of a solution of ethanol in water in which the mole fraction of ethanol is 0.040. Assume the density of water to be 1. We have ethanol as our solute and water as our solvent. So this data is clear from the question. Now we are asked to calculate the molarity of ethanol. We know that molarity is equal to number of moles of solute, here it is ethanol, divided by volume of solution in liters. So this is the equation that we are following to calculate the molarity of the solution. Now let us consider the volume of the solution, in this case, to be 1 liter. Now we have another data, that is the mole fraction, which is given to us as 0.040. From this we can say that since this is a very small value, the volume of solution should be almost equal to the volume of water. We have assumed the volume of solution to be 1 liter. Therefore, we can say the volume of water to be 1 liter. Now, density is equal to mass by volume. In the question it is provided that density is 1. Therefore, we can rewrite this equation as mass is equal to volume. So, we get the mass of water to be 1000 grams. Since we have the volume of H2O to be 1 liter, we can say the mass of water is 1000 gram. Let us try to calculate number of moles of H2O or the solvent. We know that it is equal to the given mass upon molecular mass. Now let us substitute the values. We know that the given mass is 1000, which we have calculated, divided by molecular mass of H2O, it is 18 gram. Solving this, we get 55.55 moles. So this is the number of moles of H2O. Now let us look into the equation of mole fraction. We know that mole fraction of ethanol is equal to, this is of ethanol, so we can write this as number of moles of ethanol divided by number of moles of both ethanol and water. I know this equation is familiar to you all. Now let us put the values that we already know. We know that the mole fraction of ethanol is 0.040. This value is given in the question. Now we don't know this value of number of moles of ethanol. So let us keep it there. Divided by number of moles of ethanol. We can keep it there, and then we can substitute the number of moles of water, which we have calculated as 55.55, to find what is the number of moles of ethanol. So now for easy, let me put X as the number of moles of ethanol. So I can rewrite this equation in this way. 0.040. What do? Let me just cross multiply. So we get 0.040 into X plus 55.55 is equal to X. We can write it as 0.040x plus 2.222 is equal to X. Now what do? I bring this value over this side, and we get 2.222 is equal to X minus 0.040x. If I take the common X out, I can write it as 1 minus 0.040. So we can write this as X into 1 minus 0.040 is 0.96. Now to get the value of X, all I have to do is I have to divide 2.22 by the 0.96. Solving this, we get 2.314. We know that X is equal to the number of moles of ethanol. We have calculated the number of moles of ethanol to be 2.314. Let us come back to this equation of molarity, where we know this is equal to the number of moles of solute. Here it is ethanol, so we'll write it as ethanol by volume of solution in liter. And here we have considered the volume of solution to be 1 liter. So this molarity will be equal to the number of moles of ethanol, that is 2.314, divided by 1 liter, that is 2.314 molar. So this is the molarity of the solution that we were talking about.